Thanks, Susie. I'm going to actually go reasonably quickly through this because I'd like to get Bob to, talk more in detail about the next phase. So just a very brief overview of what we've done so far. So our main research challenges, initially looking at the host range of Ostreopuccinia cityi in Australia and the susceptibility particularly of our native Myrtaceae, really helping us focus where we're going in terms of assessing impact in our native ecosystems and all the associated environments. So to date, and I always these days just put greater than 350 species because every time I give this talk the number seems to increase. We know it's roughly 58 genera from which these species are included. To date we've assessed 163 species under field conditions for both impact and susceptibility. Some of these are just in collections like Botanic Gardens, but many of them we've actually done across their native range as well. So we're looking at roughly 30% of what we consider as highly or extremely susceptible. Some of those we haven't been able to identify any levels of resistance. Some, fortunately, there are good levels of resistance, but we need more work on those side of things. We have more detailed studies on a range of species looking at provenance or population variability and susceptibility, but those have been more focused on ones that have got significance from an industry perspective, particularly the eucalyptus, Corymbia, more recently the Backhausia, with Emily Lancaster doing a PhD with the CRC. A number of this work is already published, and there's more papers coming out, particularly looking at some of the genomics of resistance within the eucalypt populations. So just looking from an impact on species perspective, there are a number of species that are on a rapid trajectory of decline, going rapidly towards extinction, unfortunately. This is one of those examples. This was a common species, widespread distribution across New South Wales and into southeast Queensland, and quite common within fringing rainforest areas, and known as a pioneer species. Rust very rapidly affected this right across its range, affecting all life stages, to the stage where we just don't see any regeneration of this species. There's no flower or fruit production at all. All matured trees are either dead or dying, and any coppice or epicormic regeneration is severely affected. So you can see just on the table I've got below, just from our 2013-14 assessments, where we had populations ranging from 12% through to close to 100%. Two of those sites are already seeing localised extinction, and the other, there's been a significant increase in deaths within that species. So we're now starting to see effects at a greater level. So rather than just individual species, we're seeing whole communities. And this is a particular study site that we've looked at in the Tallebudgera Valley, which borders on the Gondwana World Heritage Rainforest ecosystem. It's an ex-pasture crop, but it's been allowed to regenerate. And this one's fairly well established in terms of its regeneration with a well-established rainforest understory. The majority of the species are Myrtaceae. You can see there listed the four main species there of Archirhodomyrtus beckleri, Gossia hillii, Dextrospermum humuli and Ackmena smithii. Now 3 of those from the table you can see are in dramatic decline. And you can see just from 2016 to 2017 we've almost got a 3-fold increase in deaths in the 3 main species there, and the remaining of trees for those species are in significant decline. So likely in the next 2 years we're going to lose those 3 species, and then possibly a 4th with Rhodamnia maydeniana showing no evidence of resistance and significant decline. So a dramatic change within this ecosystem. That's demonstrated, as you can see from this graph, where we've got the mid-story, which is showing the existing Myrtaceae. 94% of what was there present was Myrtaceae. That's starting to shift as we get to the regeneration, so saplings coming through in the understory. And now in regeneration, we're just seeing total change. So we're not seeing Myrtaceae come back into this site, apart from a single species, and that being the Ackmena smithii. So yes, there are things coming into there. Whether it'll still transition to a rainforest ecosystem, that's something we just don't know at this point in time. We do know that some of these species that are coming in, like the white bolygum, is known as a pioneer species and comes into disturbed sites. So it's recognising that myrtle rust is a significant disturbance event. So most of you would have seen these pictures before, and this just demonstrates the rate of decline that we're seeing. The species in the background there, Syzygium coronanthem, is an overstory rainforest species. The landowners have indicated that this tree and other trees of this species in the area are around 80 to 100 years old. So this tree would be about 25 to 30 metres tall, and it already in 2014 shown evidence of decline. And if we look at 2016, you can just see the level of decline. So these things have suddenly reached a point where they've had repeat cycles of infection and they've just run out of reserves and they're suddenly collapsing. There are probably 20 or 30 other trees of Syzygium corynanthum in that area. We had hoped there was evidence of resistance within that population, but in the last 12 months we've actually identified that these are now collapsing quite rapidly, so that's quite depressing. Sorry. So delivering the message to the environment, it's been a real challenge. The uptake from the Environment Departments has been slow. The first time I actually presented to the Queensland Department of Environment, I think I had 6 people turn up. Fortunately, those 6 people were enough to get the message across, and more recently, or earlier this year, I actually had 70 or 80 attend, including a lot of the DDGs and DGs. So the message is slowly getting through. Such that in the Queensland Department of Environment, they're actually putting up a myrtle rust as a case study and using it as a bit of a catalyst for the development of an environmental biosecurity strategy. So if one good thing comes out of the myrtle rust issue, if we can get the biosecurity message into the Environment Departments, that's going to be great. As also a result of, I guess, presenting to the department, we've now recently engaged with some of the World Heritage Advisory Committees. So Bob and I both presented to the Gondwana Rainforest World Heritage Committee and the Kagari or Fraser Island Committee, and that's really resulted in more exposure to a wider range of different people. And they've both put together communiques which go to ministers level, both at a state and federal, looking for urgent funding to help assist with the myrtle rust issue. New South Wales are also developing a plan within OEH, so things are happening, but they're just ticking along. And Bob will talk obviously in more detail about what's happening from the action plan at a national level. Just as a bit of a side, some of the current research that we're doing that stem from the work we've done here at the CRC. Grant Smith is project leader for a Catalyst, an MPI-funded project, which is looking at the susceptibility of the native myrtaceae in New Zealand. So they're going through and collecting from all the provenances of all the range of their myrtaceae, both from a conservation perspective, but also for us to actually look at resistance and susceptibility patterns within those different species. Not only just from a planning and management perspective, but also a better understanding of the impact and long-term impact it's likely to have in New Zealand. We're also looking at disease epidemiology. Most of the data we have on epidemiology is from South America, and we see that this pathogen is behaving very differently in our ecosystems. There's more work that needs to be done in that area. While it's not a formal agreement, we have an arrangement with the Forestry and Agriculture Biotechnology Institute in South Africa, and we've just started testing the susceptibility of our myrtaceae to their unique strain they have in South Africa. And I've just come back from there and finished our first lot of testing, which would suggest it is just as aggressive as the pandemic strain that we've got here. So there is a threat, obviously. We've seen some talks about wind spread from South Africa into Western Australia, so there is a threat that could be an issue. From the Australian perspective, there's still some ongoing but fairly minor activity from the industry side of things. Some of the food and oil industries are developing breeding strategies, and we're integrating rust screening into those programs. For example, in the tea tree program, they're trying to identify new varieties, and so we're just screening that material on top of that variety selection. Lemon myrtle is ongoing. There's hope that they'll identify new populations to introduce from a commercial perspective. There's a lot of activity, not only in New Zealand from the leptospermum side of things. Supposedly our honey and products are better than New Zealand's, but we won't hold you any competitions there. Environment side, there's next to no current funding. There are a few little activities going on, but any formal arrangements hopefully is going to come out of what Bob is going to present. So just very quick thank you to Angus, Fiona, Peter, Gordon and Susie, and the PBCRC for their ongoing support. Thank you.
Okay, take team. Bob Makinson, ageing taxonomist. Myrtle rust is the third warning bell for the environmental sector in Australia. The first one in terms of broad-scale pathogens, I should say. The first one, of course, was Phytophthora cinnamomi, been here more than 100 years, has done immense ecological damage in Western Australia, and has brought a few species to right on the brink of extinction over there and reduced many others. The second warning bell for the environmental sector in terms of pathogens was chytrid disease of frogs, which appeared in Queensland in 1993. Myrtle rust is the third one, and the environment sector has not yet got its act together in terms of how to anticipate and how to respond to these broad-scale environmental pathogens. The initial response to the establishment of Ostropaccinia posidii in Australia was, of course, led by biosecurity and plant primary production bodies. And I've got to say that while one could quibble about particular aspects of that early response, overall they've done an excellent job. Moreover, certain bodies, the CRC, notable among them, and Plant Health Australia, with Commonwealth funding, have sustained a level of research, some of which has had a direct bearing on the environmental situation. And the work of Jeff and his opposite number in New South Wales, Angus Carnegie, has been absolutely pivotal to getting a handle on the environmental declines caused by this pathogen. And there's been some significant work also at Macquarie University and the University of Tasmania. However, Australia has yet to mount a coordinated environmental response to the pathogen. The agencies have been caught at a bad time with it. It's a period of contraction and expertise loss in most of the environmental agencies around the country at the moment. And there's limited expertise with pathogens, plant pathogens anyway. So there's a continuing need to draw upon the biosecurity and plant health sectors for that expertise. Secondly, there's something about myrtle rust that engenders a certain fatalism, and its airborne nature and its extremely broad host range, of course, are part of that. So we've had no coordinated monitoring program and therefore no data on which to sort of generate things. So really the point of the project that I've been involved with has been twofold. Firstly, to provide by synthesis and assembly of information a more easily available evidentiary basis on which to try and galvanise an environmental response. And secondly, to develop a draft action plan which would cover at least enough basis to enable the fairly rapid standing up of the response that's been lacking for the last 8 years. One of the factors that does bear dwelling on is that the review component, the first component there, does aim at getting a synthesised form of information out to a lot of people who simply haven't got access to it at the moment. Most of you have seen stuff on myrtle rust. A few people in environmental biodiversity science areas have seen stuff on myrtle rust, but not very much because they don't read your journals. And a great part of the environmental sector doesn't read the journals of either of our sectors. So information flow outside our silos and between jurisdictions has been pretty limited, and an information hub is actually one of the things that we're focusing on as a priority. So, current geographic extent, well, the graph at top left there shows the East Coast, Northern Territory situation. It's still patchy in the top end, and we're not sure how it's going to behave up there. In Victoria and Tasmania, it's marginally naturalised. It's only in cultivated and nursery situations there so far. Possibly climatic partly, but also a lack of highly susceptible hosts, I suspect, in the bush on which it's conspicuous. So it hasn't been detected in native bush down there yet. The climatic models, climatic suitability models vary considerably for the southwest of WA and drastically for the monsoon tropics. Nobody's sure what it's going to do up there. But they do concur that portions of southwest of Western Australia are vulnerable to the establishment of the pathogen. And the map at top right there shows the density of Myrtaceae species in WA, which has more than half of our native Myrtaceae, and 1,000 of them are concentrated in those moist, southwesterly most IBRA bioregions, the ones in dark red. The strain in Australia so far has infected 394 taxa here, of which 358 are native species or subspecies, plus some hybrids. That number, as Jeff said, is going to rise. Laura Fernandez is here, has another 17 from inoculation screening, and there's a few more just been reported last week from the wet tropics. Some tribes and some genera are highly prone We're getting to a level of dangerous levels of heavily infected species in some genera now, and it's not out of the question that we could be looking at genus level extinctions down the track somewhere. So particularly in Lenwebia, where 4 out of 4 species are severely affected, and Rhodomyrtus also, and Rhodamnia is not far behind. The review and the action plan identify 45 species as being as needing priority conservation action of one sort or another. 4 on an emergency basis, where they are really right on the edge of extinction in the wild, or will be so within the next probably 2 years at the most. Another 12 of very high priority and 29 of slightly less high priority. Many of these species require urgent germplasm collection if we are to preserve any options for future recovery through resistance breeding or reinforcement of populations with resistant genotypes. For those of you who weren't at the Myrtle Rush breakfast this morning, I'd like you to meet Lenwebia species main range. It's on the border ranges between Queensland and New South Wales. It's a cloud forest specialist, and say hello and say goodbye, because this is very likely to be the first species to go extinct in the wild as a result of myrtle rust. You can see what it's done to that plant in the shot in the middle of the screen there. The 2 plants in pots are the only cuttings that have been salvaged to date from very, very poor material available in the wild. The main ecological communities affected, of course, are the East Coast rainforests, and we've just had a bunch of data in from Jarrah Wills for the wet tropics. The situation is somewhat worse up there than we had anticipated or had thought, although we had suspected it. The East Coast heath woodlands and the Melaleuca wetlands. Now, of these, declines and loss of species in all of these are important and will have knock-on effects, but possibly the system with the most dangerous, if you like, or the most conspicuous knock-on effects will be the Melaleuca wetlands. If there's serious decline in those, the potential for cascade effects down to both aquatic and terrestrial biota are really significant. There's not many other trees can take the place of Melaleucas, broadleaf Melaleucas, in those situations. They generate a lot of biomass, they capture a lot of carbon, they hold a lot of soil together, and they provide a lot of shade over the aquatic systems that are involved. So it's a big issue there as to what happens. Cultural impacts have not been explored at all in Australia as yet. By comparison with New Zealand and Hawaii, we are well behind on that front, and that's highlighted in the review and the action plan. There are triggers for conservation concern. Quite a number of the species involved are listed in one jurisdiction or another, 18 under Commonwealth and 83 under other jurisdictions. The Commonwealth list is in some ways well behind the others in the number of entities captured. But listing status, pre-existing listing status, extinction risk status is not a sure guide to prioritisation for myrtle rust. 2 of those 4 emergency species that I mentioned were previously widespread and common. So listing status needs to inform our prioritisation, not determine it. The draft action plan's organised under a couple of overarching recommendations, the first one of which and the first 2 themes are to do with enabling the response. It's trying to provide basically a pop-up sort of action framework for governments and for the wider non-government sector. The remaining themes and the items in red are kind of the operational priorities at a field or laboratory level, and we're advancing actions under each of those not shown here. So I hope you will have a look. There are some copies of the action plan. I'm not sure it's enough for everybody, but there are copies of the action plan on the table out in the foyer, and it will be up on the Foundation website very shortly. The review is lagging slightly behind, but it will be out during June and will be on the same website. Thank you very much.